This is the solution to problem number 6 from the final exam review for ELC 4335. Okay, in this problem we have a block diagram, and maybe it looks a little intimidating, but it fits the form. We call it a canonical form for realizing a given transfer function. And so if you go back through your notes, I think you'll see that you'll be able to, for example, look at this block and write down the answer by inspection. Okay, so let's talk about that for a second. Okay, what we notice here is we have some feedback passed through an integrator. So here's the integrator. This feeds back. It's positive feedback here because this does add, and this is the form that we did for deriving this form of a transfer function realization. But basically, to get this blue block, okay, so this part of it, okay, you can write down the transfer function by inspection. And remember, the blue block's in parallel with the upper block that we'll talk about in just a second. Okay, so to write this down by inspection, we would get that y of s over r of s, and that's for this lower block. Okay, so maybe we should call this y1 because we're omitting the upper half. So y1 over r of s is going to be, well, what we notice from the canonical form is that this would be s squared because we have two integrator blocks. Okay, and then the coefficient for s is the 4 plus, it's minus a feeding back. So positive a would be 4, and then this would be 3. Okay, so that's the structure. And then on the top, there's just a 3 on the output. Okay. All right, so that's the upper half. And so if I wanted to do, this is the lower half. If I wanted to do the upper half, it fits the same form. All right, so here's our upper half. Okay, and so we would read this off as plus 2, the 2 here, and then we have an integrator, and then this is feeding back, so this would be s plus 5. Okay, so this is our overall. At this point we can get rid of the 1. This is our overall transfer function. Okay, so that's the answer to part A. All right, so in part B, we were wanting the steady state error, given that the input is a unit step. So, this doesn't fit the normal feedback structure that we've seen in several problems in this class, and so you have to define what error would be. What we've done in this class is that the error, E of s, is usually taken as r of s minus y of s. Okay, so given that, we can now plug everything in. We know that r of t is a unit step, and so r of s is 1 over s. So that means for E of s, we have 1 over s minus y. Y is already in a partial fraction form. That's okay, we can just leave that. Minus 3, or s squared plus 4s plus 3. Right, and to get y of s, from y of s over r of s, I need to multiply by 1 over s. Right, so let me write that down over here. Okay, so those would cancel and get y. So that gives me an s in the denominator for both these terms. Okay, so there's E of S. Let me clean this up a little bit. That is frustrating. Okay. To get the steady state error, it is the limit as t goes to infinity of E of t, and we have E of s. So the final value theorem from Laplace says take the limit as s goes to 0 of s, E of s. Okay, so when I do that calculation, limit as s goes to 0 of s, E of s, so I can, I have E of s right here. Okay, so I substitute that in. This would be s times 1 over s minus 3 over s squared plus 4s plus 3 over s plus 2s over s plus 5. And you see the s's cancel. Oops, not that one. Okay, so the free s's cancel, and I can let this limit, let s go to 0, and I can plug in and get finite numbers. So that would be 1 minus, okay, and this term would be 3 over 3, and then minus 2 over 5. Okay, so the 1 cancels with the 1, and our final value theorem in this particular case gives me an answer of ESS is equal to minus 2 over 5. Okay, I wanted to add a discussion to the solution for problem 6. Suppose that you forgot to put the canonical form of a transfer function realization on your formula sheet, or you just didn't recognize that that was what this problem was about. Would you have been stuck? And hopefully the answer is no, because you can tell, let's just look at the upper block here. I've repeated the upper block here. It looks like a feedback structure, only it's not negative feedback. And so the first thing you could do is get the eraser out and change this to negative feedback, which would change the plus sign here, the minus sign here to a plus 5. Okay, and now this plays the role of G, this plays the role of H, and so for this particular section, the transfer function would be G over 1 plus GH. Okay, so 1 over S divided by 1 plus 1 over S times 5. All right? That's the part in the box. So we multiply top and bottom by S, and we would get 1 over S plus 5, just as we did before. And so that's showing up at this point in the block diagram. And then to get y from that, you just multiply by 2. Okay, so we've essentially derived, without knowing that canonical form, that the transfer function is 2 over s plus 5. Now I agree the lower block is more complicated. You'd have to do that twice because it's a